is from your practice test. So does the integer k have a factor p? So we're trying to figure out if p goes into k evenly. And that would have to be an integer for p to be a factor. They also tell me that p is in between 1 and k, not including 1 and k. Well, the first clue says k is greater than 4 factorial. Well, to review 4 factorial, 4 factorial is 4 times 3 times 2 times 1, and that's 24. So k is bigger than 24, but it doesn't tell me anything about p, so that's nothing. Let's look at clue 2. Clue 2, the smallest, it says k is in between that 13 factorial plus 2 is less than k is less than or equal to 13 factorial plus 13. So let's look at the smallest number in here, which is this one. So that's 13 factorial plus 2. Well, we're trying to figure out if k has a factor. We're trying to figure out if the integer k have a factor of p. Does the integer k have a factor of p? All right, so if you think about 13 factorial plus 2, 13 factorial is 13 times 12 times 11 on down to a 2. Then you got that plus 2. So 2 goes into this, and 2 also goes into that. You could write this as 13 times 12 times 11 dot 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 down to 2 plus 2 over p. So remember, p is in between 1 and k. So let's say this number is definitely divisible by 2, right? 2 would go into this piece and 2 would go into this piece. And we're going to work our way up to where p is actually this number. If you looked at the next one, 13 factorial plus 3, is there a 3 here? Is there a 3 here? Yes, there is. So if it was 3, p would go into it evenly. And you can use that same scenario all the way up to 13 factorial plus 13. There's a common 13 here, and there's a factor of 13 there. So yes, does the integer k have a factor p such that p is in between 1 and k? Yes.